Today we're going to talk about constant motion. You'll recall that the change in distance represented your final position minus your initial position. This is often called displacement. If you're on a highway and you're driving forward, you cover a certain distance in a certain amount of time. We can take the rated change of position, delta D, and divide it by how long it took us to change that position, delta T. This will give us our average velocity. Notice that velocity is a vector, so it has both size and direction. It is important to know the difference between velocity and speed. Speed is just a number, but does not have an inherent direction. For example, if we say 60 miles per hour, we don't know what direction we're heading. Velocity, on the other hand, is a vector. It gives us more information. So if I say we're going 60 miles per hour northbound, we now know how fast we're going and in what direction we're heading. Let's use the v-average equation to solve a few problems. Example 1. We have a car driving at 65.0 miles per hour north on the highway, and it does this for 2.50 hours, and we want to know, how far did it go? The problem gives us the average velocity of 65 miles per hour. It also tells us how long we were driving. In this case, T is going to be 2.50 hours. Using our equation, we know that 65.0 miles per hour is going to be equal to the change in distance, all divided by 2.50 hours. We have to do a little bit of algebra to get delta D by itself, so I'm going to multiply both sides of the equation by 2.5 hours. This gives me delta D equals 65.0 miles over hours times 2.50 hours. Notice we have hours on the top and on the bottom, and they cancel out, giving us only a unit of distance, which is what we're looking for. Now our calculator will tell us 162.5 miles. We have to round this to the correct number of sig figs, 3 in this case. So for our final answer, we will say the change in distance is equal to 163 miles north, meaning we traveled 163 miles further north than where we started the problem. Let's do another example. Here we have a classic track and field problem. How fast are you going if you can run 1,610 meters in 5 minutes and 33 seconds? Let's start by writing what we know. So our change in position is 1,610 meters, which happens to also equal 1 mile, if you're curious. The change in time, as given, was 5 minutes, 33 seconds. Now, in order to make a calculation, we have to convert this all into seconds. So this is equal to 333 seconds. Using our equation, we have V average gives us delta D over delta T. In this case, 1610 meters divided by 333 seconds. We plug this in and round it to the correct number of sig figs, 3 in this case. We get 4.83 meters per second. Let's do one more example. So how long would it take if we were to travel 537 kilometers with an average speed of 85.0 kilometers per hour? So this particular problem is asking us to find the time. We know the change in position was 537 kilometers, and we know our average velocity of 85.0 kilometers per hour. Our equation allows us to set this up. 85.0 equal to 537 kilometers over delta t. Now here we got to get delta t by itself. So we have to multiply each side by delta t. And then we have to divide each side by 85.0 kilometers per hour, which is a few algebra steps later. We get delta t is equal to 537 kilometers divided by 85.0 kilometers over hours. If we go ahead and plug this into our calculator, we get 6.32. But the units are a little weird. The kilometers canceled out, but we're left with this compound fraction. So we have to do a bit of simplification, which gives us a delta t equal to 6.32 hours. So remember, for all these problems, double check your answer. Does it make sense? Are the units what we're looking for? In this case, time was what we were looking for, so hours make sense. And it should take us a decent amount of time to go 537 kilometers. So everything looks great here.